So in other words, it's in 6 days. It seems like a long way away, but I think I counted right. Okay. Change into degrees. 7 pi over 10. We should be able to do this with our hands behind our back. This is 7 times 180 over 10, right? Which is 7 times 18, which, 126. So 126 degrees. Now, changing into radians is not as easy. To change this into radians, we set up a proportion, right?
Yes.
So pi over 180 never changes, and then x over 200 in this problem. So 180x equals 200 pi, and x is 200 pi over 180.
Can I go pre-test tracking?
Well, you have to go back and see when you're not here, you gotta take care of yourself. So 20 over 18 is 10 pi over 9. We do need to reduce, so do that. Somebody should tell them where they are back there. All right. Yes. Up here. The big thing. The measure, find the measure of the arc. This is the 2-part problem. This is the one that you really have to pay attention to because there's 2 pieces to it. We want to find the measure of the arc right here. So this is the arc. An angle of 100 degrees in a circle with a radius of 8. Now, when we say find the measure of the arc, something should pop into your head. Arc length is radius times radians. Now, what's the matter? We have degrees, and we need radians. We know the radius is 8, that's good. But we need the radian measure. We have the degree measure. How do we change a degree into a radian? We just did it. What do? Pi over 180 equals x over 100. So 180x equals 100 pi, and x equals 100 pi over 180, which is 10 pi over 18, or 5 pi over 9. That is exactly what we just got done doing. The difference is, when we did this one, we were done. That was the answer. We are not done here. Now we have to take this radian measure and put it into our formula. So we're going to take 8 times 5 pi over 9, which straight across 40 pi over 9. And that is the answer to the question. So that's one you might want to go back and redo on your own just to make sure that you remember to do both parts. You have to find the radian measure of the angle, and then you do radius times radians. Okay? All right, next. All right, this time I'm going to pay real close attention to this. Don't want to mess it up. What does that tell me right there? What does this mean? I am between 90 and 180, which puts me where? 0, 90, 180. Doesn't it put me over here? In math land, when you measure angles, this is how you measure them. So 90 to 180 is right there. Now I know that the sine of the angle that I just drew is 2/5. So if the sine is 2/5, won't I label my picture like this? 2/5. And then the third side, I'll need to figure that out. How will I figure out the third side? Pythagorean theorem. And I'm very careful when I do my Pythagorean theorem because a squared plus b squared equals c squared. This has to be the hypotenuse. So I don't square these two and add them together. This squared and this squared have to be that squared. That's the hypotenuse. So 4 plus b squared has to be 25. So b squared has to be 21, and this is the square root of 21, and it is negative. Right?
Yeah.
Okay. Excuse me. All right. So now I ought to be able to fill everything in. What's the cosine? Remember, here's your angle. What's the cosine? Perfect. And what's the tangent? So it's 2 over root 21 negative, which is exactly what you said, negative 2 root 21 over 21. And then we'll just do the reciprocal. So this is 5 halves. This is negative 5 over root 21, or negative 5 root 21 over 21. And this is negative root 21 over 2. Ethan, why are you on your watch?
I'm checking my heart rate tonight.
Oh, okay. That's an excuse. We'll let that go. All right. Number 5. Find the exact value. So we got a bunch of this. So here we go. Cotangent 300. First thing you're going to do is draw 300. Now remember the setup. Where is 300 going to be in this? Right down here? So quadrant 4, here's 300, perpendicular up to the x-axis. Some of you are still drawing those in crazy places. Goes up to the x-axis. How big is this guy right here? He's the important one. That angle at the origin is so important. How big is he? 60. Because all the way around is 360. Across from the 60 is root 3. And is anything negative? I need to keep track of that. Is anything negative? The 2 is never negative.
No, 5 is never negative, that's right.
No negative on the hypotenuse ever, right?
Root 3.
The root 3 is negative. Cotangent. What's cotangent? Adjacent over opposite. So 1 over negative root 3 or negative root 3 over 3 is your cotangent. Oh, this next one's kind of wild and wacky. Sine of negative 420. It's going to go around more than once, right? Because what's all the way around? 360. Plus, it's negative. So this would be negative 360. And then how much farther does it have to go? 60 more? But it's going negative now, so make sure you're coming down and around, right? Ooh, I think it's the same triangle I just drew over there. All the way around is 360. This is 60 more than that, right? So 60 more than that would be down another 60. So we have our 1, our negative root 3, and our 2 again, but this time we want the sign, and the sign is negative root 3 over 2, opposite over hypotenuse. Now this next one, this is that notation that means find the angle. So there's an angle out there that has a sine of 1 over root 2. That's what, see the little inverse notation, the little negative 1? That, you don't see it in this problem. You see it in problem C though. It means find the angle. Tell me what this angle is if the sine is 1 over root 2. That's a 45-degree angle. So the answer, plain and simply, is 45 degrees. That's the angle that if you do it sine, you get 1 over root 2. This next one I will tell you it's in quadrant 2. And the cosine is negative 1/2. So adjacent is negative 1, and hypotenuse is 2. Okay, so that makes opposite root 3, and that makes this angle 60 degrees. Very good. Now, if you've done all that, you're right there. But don't put 60 as the answer. 60 is not the answer because you have to start over here and go all the way around like that. So that's not 60. That would be what? 120. That's 120 degrees. So the answer to the question is 120.
So when it's negative, do you do that? You go all the way around?
What do you mean?
Because it says negative 1/2.
Well, that means it says what?
Negative 1/2.
Yeah, that's how come it's in quadrant 2.
Okay, so why do we go like all the way around?
As opposed to doing what?
The other A, B, and C. Yeah.
This angle is a quadrant 2 angle. It has to be between 90 and 180. Any angle you draw in quadrant 2 is bigger than 90 and less than 180.
Okay.
So 60 doesn't count. 60 is not bigger than 90.
Yeah. Okay.
Okay, so
Yeah,
you
that
gotta
makes
get
sense.
over there.
Okay.
So on the test, you're gonna give us which quadrant it is?
Only if it's negative. Only if it's negative. Otherwise, you're gonna draw in quadrant 1 every time. All right, tangent 7 pi over 4. Now this one is radians, which is fine. You can do it in radians if you want, but you might want to change it to degrees. So you'll take 180 divided by 4 times 7, and that's going to be 315. So now I'm going to draw 315, right? That's a long way around. 315 is over here like this. How much is left there? $45. So what are the sides of that triangle now? You should know that. 1, 1, and root 2, and this one is negative. And we want the tangent, which is opposite over adjacent. So negative 1, negative 1 over 1. You have another radian, so we'll change that into degrees. How many degrees is 3 pi over 2? 270. Pi is 180. 180 divided by 2 is 90, and 3 90s is 270. Wait a minute, something weird is happening. Yeah, we need the circle for this one, because isn't this 270? And when your angle is on the line, on an axis, you need to use the circle. And the radius is 1, always. So if I start at the origin and go straight down 1, this is the point 0, negative 1. I want cosine. What's cosine? X over r. Thank you, Diana. So I need x over r. So that's going to be 0 over 1, which is 0. So the cosine of 270 is 0. All right, now we have our thinking cap problem. We have to think now. The cosine is negative, and the cosecant is positive. So cosine is negative, and the cosecant is positive. Which, by the way, if the cosecant's positive, doesn't that mean the sine is positive? I think better in cosines and sines than I do in cosecants. So what the only thing this question wants to know is, where is it that you will have a negative x and a positive y? Remember, cosine is associated with x over r. Sine is associated with y. So if the cosine is going to be negative, x is going to be negative. And the sine is positive, so y is positive. Where is it that that happens? That x is negative, but y is positive? Okay? Not quadrant?
You said the x spot before?
No, but you're
Third?
sort of close. No. What happens in the third? In the third, they're both negative, right?
Yeah. Okay, so alright, I know that. I will let somebody else do it.
We're in quadrant 2. In quadrant 2, the x is negative and the y is positive. Back freshman year, down in room 4102 with Mrs. Field, you learned how to plot points. And if we plotted a point that had a negative x and a positive y, where would that point go? Quadrant 2. So the answer to the question is quadrant 2. The answer to 6 is simply quadrant 2. Those problems are super simple if you remember that cosine is x and sine is y. So if the sine's negative, y is negative. And so on. All right, now we're sketching. I got some quizzes to turn back to. So here we go. Our first sketch is a tangent. But pay attention because the tangent happens to be negative. And what does that do when you have a negative out there? Turns you upside down. So a normal tangent has an asymptote and an asymptote, and then squiggles up through the origin. This one is going to squiggle down through the origin. Okay? All right. Now, normally, the only thing you have to label are these. So normally it's negative 90 and 90, right? That's the normal. What's happened this time though?
Times 2.
We divided by a half, which is timesing by 2. So this is going to be negative 180 and positive 180, which means our period is 360. And like all tangents, our amplitude is none. None. No amplitude. Okay, sine 3x. So this is a sine curve, regular, right side up. So I know my shape of a regular sine curve is that. And if I don't know that, I better figure it out. That's what a sine looks like. How high and low does this guy go? 1. We didn't change that. This is the normal, and since there's no number out there, that's what it is, right? It didn't change. These normal labels are 90, 180, 270, and 360. Always for a sine and a cosine. On the quiz, some of you were getting numbers. I do not know where they came from. It's always 90, 180, 270, 360. But what's happened, we've divided them by 3. So the actual labels are 30, 60, 90, and 120. Which means my period is 120. And my amplitude is 1. Amplitude's the height of the hills. 1.